Our planet is home to an abundance of life. Over 8.7 million species are estimated to live on Earth, with millions yet to be identified. However, in relatively recent years, a newfound curiosity has shifted attention towards another possibility: extraterrestrial life. Since the mid-20th century, active ongoing research has taken place to look for signs of life on other celestial bodies in our solar system. Although many missions were able to conclude a low likelihood of life on planets such as Mercury, Saturn, and Jupiter, there are still a number of other places where current life is considered feasible. The first and closest of these places is Mars. Since the 1970s, missions such as Mariner 9 orbiter have sent back a number of photographs showing water-carved landforms. Alongside these images of carved-out streams and rivers, etc., hillside gullies and other apparent channels signify that running water may exist underground. Subsurface running water would mean that Mars also has some sort of energy source as well, most likely interior geothermal heat, which leaves organic molecules as the third necessity for life, in which Mars is most compelling. Spirit, Opportunity, and Curiosity are rovers that have yielded a great amount of information on the compounds present on Mars' surface. Their discoveries of iron oxides, carbonates, hydrated sulfates, silica, and mineral-rich clays have surmised that locations such as Gale's Crater and Gusev Crater may have been a potentially habitable environment. However, these discoveries are not necessarily evidence of life itself. In fact, many of these findings were derived from sedimentary rocks or sites billions of years old and are likely leftovers from the period in Mars' history when the environment was significantly warmer and the atmospheric pressure was higher. With its current conditions, critics argue that life is not possible on Mars, and we would have to agree. The discoveries made by the twin Viking landers of the 1970s revealed that with such a thin atmosphere, high-energy ultraviolet radiation from the sun bathed Mars' surface continuously. Not only do UV rays devastate any organic molecules that may be, but the soil itself has been found to be laced with perchlorate, which also breaks down organic molecules. Although evidence supports that a more active Mars once existed billions of years ago, based upon current conditions, we find it highly unlikely that life exists there today. The next location is Saturn's moon Titan, which offers a lot of eccentric quirks to consider. It is the only other world besides Earth that is known to have an active rain cycle, but unlike the one on Earth, Titan's rainfall yields liquid methane, which flows into deltas, rivers, and streams. Not only this, but a separate kind of precipitation brings a steady drizzle of hydrocarbons, and the combination of sunlight and radiation from Saturn brings the compound vinyl cyanide into the mix as well. Vinyl cyanide supports the idea of extraterrestrial life on Titan because it helps to assemble membranes like those found in living cells on Earth. However, despite its various compounds that may assist in the progression of life, a greater issue seems to hinder the chances of life on Titan dramatically: its cold temperatures. Receiving just 1% of the sunlight that Earth does, it's no surprise that Titan has some extremely low temperatures. With a surface temperature just around negative 290 degrees Fahrenheit, many speculate that it'd be extremely difficult for life to exist on Titan. However, astrobiologist Christopher McKay has been experimenting with the solubility of organic material in liquid methane and ethane, hoping to demonstrate what may be an exception to Titan's relentless temperatures. McKay claims that although such coldness would drastically slow the speed of reactions, it may be a good thing in the case of Titan, because if everything is slow, you don't have to work very hard. You don't need a lot of energy. Titan has a very frigid facade, but below the surface, a gentler environment is suggested to exist. Through the study of shifting crusts and land masses on Titan's surface, scientists have been able to determine that 60 miles down, a sea of dissolved sulfur, sodium, and potassium offers another chance of life. It's been speculated that diapirs may carry minerals from Titan's core upwards into the subsurface ocean, which would provide life-empowering minerals. This, however, is still a mere speculation. Because of the fact that Titan lacks both stable liquid water and the energy to maintain a higher temperature, my group has ruled out Titan as being likely to host life. Next up is Jupiter's icy Galilean moon, Europa, which proves promising in that it has a lot of shared characteristics with Enceladus. Despite the extremely cold surface temperatures of just around negative 260 degrees Fahrenheit during the day, its 125-mile-high vapor plumes that erupt routinely from geysers around the moon prove that there's a great deal of commotion going on below the surface. Much like Enceladus, a subsurface ocean lies beneath a cover of ice, which has been stable for billions of years. Europa's ice sheet just happens to be much, much thicker. However, in this case, a thick ice sheet is what increases the chances of survival for life forms on Europa. Being a moon of Jupiter brings both pros and cons. Because of Jupiter's strong gravitational pull, the subsurface ocean is able to keep warm through the tidal energy gained from such stretching. However, Jupiter also emits a great deal of radiation, which is where a use for Europa's thick ice sheet comes in. Much is still unknown about the distant moon. However, it has been concluded that Europa hits the trifecta of requirements for life: water, chemical building blocks, and energy. Although Europa does share many characteristics with Enceladus, due to the fact that such a great deal of radiation from Jupiter reaches the planet and because of its tenacious atmosphere, Europa is still only our second pick when it comes to the probability of hosting life. Next up is Enceladus. Much was unknown about Enceladus until in 2004 when Cassini began orbiting Saturn. A streak of new discoveries on the small moon began when Cassini detected an abnormality in Saturn's magnetic field around Enceladus, which signified that the moon was active. Further investigation led to the discovery of 84-mile-long tiger stripes on the South Pole, which each released plumes of water vapor and ice grains. Following these discoveries, Cassini was able to verify that the icy crust that spanned the quaint little world was not connected to the core, and instead covered a subsurface ocean. Cassini's findings did not end there, however, for after analyzing the plumes released from the tiger stripes, it was revealed that they contain mostly water alongside carbon, ammonia, carbon dioxide, salts, and large organic molecules. Thanks to the discoveries made by Cassini, we now know that Enceladus meets all of the basic requirements for life: water from its ocean, organic molecules, and energy from geothermal activity. Scientists were able to confirm that such an energy source existed through multiple data collections, but most compellingly, the Cosmic Dust Analyzer, which discovered silica non-grains of a specific oxidation state and size that could be traced to the ocean. This is so important because these grains could have only been formed where liquid water is touching rock at temperatures of at least 194 degrees Fahrenheit. Based upon all we know about Enceladus, it isn't too difficult to imagine that extremophiles, like those found living near very hot thermal vents on the ocean floor, may thrive 790 million miles from Earth in similar conditions. This is why I'm convinced that of all celestial bodies in our solar system, Enceladus is most likely to host current life. Honestly, we don't believe that there are any other places with a greater likelihood of hosting current life than the previously listed worlds, but since we have to, we'll talk about Ganymede. Ganymede is the largest satellite in the solar system, larger than Mercury and Pluto and only slightly smaller than Mars. It could easily be classified as a planet if it were orbiting the Sun rather than Jupiter. The Moon likely has a salty ocean underneath its icy surface, making it a potential location for life. In 1996, astronomers using the Hubble Space Telescope found evidence of a thin oxygen atmosphere. However, it is too thin to support life as we know it, and alongside the fact that nighttime temperatures drop to below -315 degrees Fahrenheit, we find that it is unlikely that any living organisms inhabit Ganymede.